All right, guys, I'm going to start to catch up to you a bit. That's what I get for the frequency there. 7, 10, 20, thank God. Adds up to 20. And then for the histogram, I just want to go up to 6, so I can just do 1, 2, 3, 4, 5, 6. Put freak in there. Freak. Heights. Fathers. And then, since I did it this way, I've got to do the up and down by a half thing. Did anybody do it the other way? It would have been, for this first class, for example, it would have been 65 less than equal x less than 67. So you can actually see the 2 class width already. And then this would have just been 65, 67. So much nicer. It's like, well, you can do it either way. And then how tall is the first bar? Just goes up to 1 and so forth. And then 2 6s in a row. Woo. And then a 3. And then a 4 to finish it. Bam. Now in this case, since it's such a small sample with such a small range, even if you try to use 6 classes, it would still come out with a width of 2. Technically, you could make it a width of 1.5. I have no idea why you'd want to do that to yourself, but you could. And then you would have 6 classes. Okay, maybe. How's everybody feel about that first? Is that right? This is what you're going to have to do on this quiz on Wednesday. Construct your own histogram. All right, how do I do this, part B?
17%.
Yeah, so the first step, 17% of 20. So 0.17 times 20 is 3.4. What do I do with that? Round it up to, that's crazy. So what's the fourth number? 67? Yeah, I think so, yeah. Shaboo! Beautiful, yes. And then define P72. Amazingly enough, I do the exact same thing. What's 72% of 20? 14.4, so you round up to 15. The 15th number is, who is it, 72? Yeah. Bam. So that's kind of weird. I didn't do that on purpose. The 72nd percentile is 72, but oh well, that just happens. Coincidence. Now, I'm really sorry about this. I should say height. These used to be grades, and then I changed it to father's heights. So it should say, but screw it. Doesn't matter what I really say here. What's it mean if you're at the 35th percentile for heights or grades? It just means that you are taller or scored higher than 35%. Scored lower or are shorter, depending on if you look at grades or height. I like it. Okay. And then this guy finally, so I want low, easy, Q1, Q2, Q3, high. So the lowest was, what was it, 65? Highest was 73. Those two are easy. I did 2 of them. Q1, so I want basically 1/4 of 20, so I get 5. You guys with me?
Mm-hmm.
So then I have to average the 5th and 6th. And what are the 5th and 6th numbers?
68.
They're both 68. That kicks ass. That's easy. Half of 20 is 10, so average the 10th and 11th. 10th and 11th are both So that's 70. You guys with me? It's awesome when they're both the same number. Holy shit. And then Q3, 75% of 20 is 15. So take the 15th and 16th one. They're both, oh, that's beautiful. Don't get used to that. But in this case, it was beautiful. What kind of scale do you guys use? Sure.
Starting at 60.
Scale of 1, yeah, you could do that. You only have to get up to 673, all right? Let's try that. Let's see, 65, 66, 67, 68, 69, 70, 71, 72, 73. Get out. So 66, 67. Show off my awesome counting skills. You could have done scale of 2, whatever. All right, but this is such a small range. Might as well do a decent scale, little tiny scale. So 65, 68, 70, 72, 73, box, whiskers, done. Let me ask you right now, let's see who remember what I said. What's the IQR? Interquartile range. What is it? Sweet, so what is it here? 4. Which kind of makes sense. The range is high minus low. The interquartile range just goes one step in on both sides. So that interquartile range phrase makes complete sense. Okay, how's that? Is everybody cool with that? This stuff here, the percentile stuff, will not be on the quiz. That's the stuff we did today. The quiz just goes up through histograms, right? Chapter 1 and up to histograms. All right, so let's do this. Let's talk about some stuff you should probably already know, like mean. I think I've used the word mean already. Maybe. Anybody know what the word mean refers to? Average. So it's when we say average in English, we know what we mean. Did I turn that sucker on? Yes? Okay. But the word average in math means many different things. So we wanted to give the idea a different word in math. So we call it the mean. That's what we consider the average in everyday life. This is going to be where we get our first real formulas here, by the way. Turn you off. Sleep. Okay. So somebody tell me in English how I get the average of a group of numbers.
Add them up and divide them up.
I like it. Add them up. Divided by total number of data points. Right? Everybody could agree with some variation on that. That's how you get a freaking average. Math people, we don't like writing that much because we have to write it a lot. That's the whole idea of formulas, is that they are shorthand. They are a different language. They are. In this case, very much so, because we're going to use Greek letters. There was one symbol I talked about already, and it's this guy. Anybody remember how to say that guy? Did I talk about this guy already? Sigma, yeah, it was on that. Did we do a sheet with it? Sigma, it means, what does it mean? It actually means sum of. Like that, sum of, not some, like some people came by, but the sum of something. So I want you to really, really realize something about this symbol. It's exactly the same as this symbol in a sense. If I said simplify this, what is that symbol? What is that symbol? Square root. If I said simplify this, what would you say? Come on, what would you say? Simplify that. What's missing? Freaking thing I'm supposed to take the square root of, right? So the symbol by itself don't mean shit, right? Not really. I can't do anything with it. I have to have something inside of it for it to make sense. This symbol, same way. It can't exist by itself. It needs to have something inside, sum of something. So what letter do you think we use to represent all the possible data values? X, of course, it makes sense, right? Good old algebra gave us that shit. If there's a whole bunch of possible values, let's just call the thing X. So here's how we write this equation to represent this English idea. Add up all the values. And what letter do you think, just to kind of lead you, to represent the number of data points? N is correct. All right, so that's what the formula for average looks like in formula form. That's what it looks like, right? Do we really need that formula? Not really, because we know how to calculate an average. You guys with me? Sort of like, I don't need the stupid perimeter 2W plus 2L formula. Just add all the frickin' sides. I don't need a frickin' formula. You guys with me? But it still exists. There's still a formula to show you what to do. So two types of mean. What is it? What terminology normally has the word mean in it? Something we were doing earlier with that number 45 problem. What's represented by a mean? What terminology? What thing? How do I describe something using mean? Let me just tell you, because I can't really get that question right. The parameter and the statistic, right? They use the word mean. You with me? What's the parameter describe? Population. What's the statistic describe? Sample. So I want to use two different letters for mean based on, is it a population or is it a sample? So we use, you ready for this? Not really. We use this guy. Mu. It's like a French cow. Mu. This is a Greek letter. We use that. And everybody's going to write a little m, and I can't do much about that, but it isn't. It's a U with an extra leg. I've been exposed to some radiation. This means, well, that's what the book does. Screw that. This means population mean. And sample mean is X bar. X with a bar on it, and we just say X bar. Okay, I like it. I keep going back to this, not just because it happened yesterday. I always talk about this, the Super Bowl. Like Super Bowl, let's see, Super Bowl 47 would have looked like this. Isn't that kind of impressive? Super Bowl 38 would have looked like that. I mean, that's kind of like, you make that in graphics where they're all stone and they come dropping out. It's like, Super Bowl, you know, it's like, holy shit. And then Super Bowl 50 came. Super Bowl 50 was just a big fat L. That's it. That's the Roman numeral for 50, right? Did you guys notice if you watched the 53, it was of course L with 3 1s, right? That's 53. Lee. All right, that's not very, like football. Oh well, too bad for us. So look, notice how we do this. We did this just to make it seem more, like, oh. So for population, that's oh. So I give it a Greek letter. For sample, it's like, everybody's got a freaking sample. I just give it one of our letters. You see what I'm saying? It's going to be true for something else we talk about later. It's different symbols depending on if it's a population, that's Greek, or sample, that's our letters. I like it. So this is not very impressive yet. So that's the first. These are all, by the way, measures of center, ways to figure out where the middle of the data is. So the mean is an obvious candidate for the middle of a set of data. There's a much more in-your-face kind of candidate for the middle of a set of data. Let me just give this to you and ask you, just straight up. What is the middle of that set of data? 3. Is the mean of that data 3? No. So another way to describe the middle is this idea of the number that's physically in the frickin' middle. That would actually be, do you guys see how that would be the 50th percentile? So really it's just the 50th percentile. So how do you find it? The same way you find that. But this is called, what's the thing that goes down the middle of the highway? Median. So we call it the median. Because we're not very creative. The symbol for median is X. It looks like a mean that had a rough night. X tilde. There's a little bar cat just kind of like got beat up. Stumbles in the door like, holy shit. So that's the median. And it's just the number that's in the middle. That's what it is. So, just find the middle number. So in this case, the middle number is 3. So here the median would be 3. What about for this set of data? Notice something, of course. What's key about what I'm doing? Why am I being very nice? I'm giving it to you in order. So if it's not in order, you better put it in order, or else it doesn't make any sense. So what's the median there?
6.5.
Yeah, beautiful. Right in the middle. It's just like P50. You have to split the difference because there is no middle. There's no middle. So I got to take the middle of the 2 in the middle. That's the freaking middle. Holy shit. Does that make sense? So here the median would be 6.5 index. I like it. All right. Now this has so far been a little unfair. What are the 2 main categories of data? 2 main categories of data. Qualitative and quantitative, right? This can only apply to quantitative. So here's one that applies to both. Here's another measure of center that applies to both. It's called the mode. Good Lord, Jeff. And the mode is just the number that occurs the most, right? Get out of there. So there's this situation, which is the easiest situation. Let me make this an A. 1, 2, 3, 7. What's the mode? Does any number occur the most? Not really. It's like a 4-way tie for once. So there's no mode. Just no mode. What about this? 1, 1, 2, 3, 7. Obviously there the mode is 1. It's amazing. Okay? So far so easy. What about this one? Seven wins. Don't say 1 and 2 because it repeats. It has nothing to do with repeats, just which one occurs the most. So 7 wins. If I would have taken 1, 7 away, it would have been trimodal. 1, 2, and 7 occur the most. Beyond trimodal, you just go, there's no frickin' mode, right? It's supposed to tell me where the data seems to be clustering. And if the clustering in more than 3 places, it's like, they're not really clustering. Screw it. All right, and then there's one more measure of center. Oh, let's see, where am I? Oh, here. This one is called the mid-range. This one kind of is evil. What's the range again? Yeah, high minus low. I love it. So what do you think naturally the mid-range should be? The number that is the mid-range should be the number that's in the middle of the range. I love it. So how would you calculate that? Like, here's some data. How would you get the middle of the range? How do you get the middle of any 2 numbers? Find the mean, right? You guys with me? What's the number in the middle of, in this case, what numbers am I looking at? The number in the middle of 4 and 21. Find the number in the middle. That's what mid-range is. So it's high plus low. That's why it sucks. High plus low divided by 2. Why does that suck? Because range is high minus low, and everybody always does that here. But this is an averaging idea, right? So you have to add them and divide by 2. So in this case, it would be 4 plus 21 divided by 2, which is 12.5. So that would be the mid-range. I like it. Real quick word about mean versus median. Do you guys, all right, anybody here know that newspapers still exist? Do you guys? Anybody in here actually look at a newspaper sometimes beyond putting it on the bottom of your bird cage or something? they throw at your door and you're like, what the hell's this? And you put it in the big blue bin and you go about your day. And then the neighbor's like, where's my paper? All right. But there are other ways to get news. Of course, unfortunately, many of them are biased as all shit in whatever direction they want to be. But, newspapers included. But, all that shit aside. Whenever you hear about certain things, they only use one of the two, mean, median. Which one is not affected by extreme amounts, outliers? So, for example, if I was about to start working at a company, and I said, how much money can I expect to make here? And there's 4 people working there right now. There's Jim, Joe Bob, Billy Boy, and Sam, the CEO. And this is in thousands of dollars, right? You guys with me? So if I took an average, what's the average of those? Somebody help me out. What's the average of the sample of people here? Oh my gosh, I think it adds to 666, doesn't it? Oh, float and start turning. Oh, no, we're all safe. Does it?
Yes.
Yeah, of course. So 666 divided by 4, right? 1, 2, 3, 4. Yeah. So if you told him you can expect to make $166,500 a year, is that honest? He's going to be one of these poor schmucks, right? And some of you guys are like, what do you mean schmuck? That's a lot of money. So what would be better? What's the median of this data? 40.5. I like it. So if you told him $40,500, or if you want to sound more human, $40,500, that would be more honest. Do you guys see what I'm saying? So of course the mean is affected by outliers because the mean considers all the data points. Does the median consider all the data point values? No. It just looks for the middle. So what do you always see reported in terms of median? Income. We're in San Diego, so freaking housing price, right, is going to be the median, not the average. Holy shit. Even if you report the median, people are still like, I can't live there. But if you report the average, they're like, no. I'll drive around, look at the houses. You with me? Kind of? Okay. So there are situations where the median is better than the mean, but for the most part, we will use the mean in this course because it's the one that considers all the values. But the median does beat it out sometimes. So, on the reverse of that paper, do this. You ready? Do this. Find 3 other people near you because you want to be able to divvy up this work. Find 3 other people. Yes. Oh, you're good. To work with. On the reverse of this paper we just were working on, there's a data analysis exercise. See how there's 4 sets of data? See that? So if you have 3 other people, you can each tackle one of them. If you don't want that, that's up to you. You can be one person working on all 4 with the shit, right? Try to find some other people near you. Don't force me to put you into groups. You don't want that. You can turn around and stuff too, like we did. Look at that. It's happening. Okay, I like it.